Hey, welcome back. Today I'm going to be walking you through point mutations using a made-up example species I'm calling Bunthera. Because they are fictional, their mutations don't reflect real-life animals, and I'm going to be taking some liberties with it. Alright, so we're going over the original wild-type DNA with mRNA with no mutations. So from the template DNA strand, we're going to get our mRNA for making proteins. I went ahead and wrote it in the 5' to 3' direction for simplicity. I have also highlighted the reading frame so you can see that this protein is 5 amino acids long. It includes methionine, valine, arginine, phenylalanine, lysine, and then a stop. In the fictional Bunthera, this protein plays a big role in the pigment production, mainly in the form of patterns. The wild-type animals have tiger stripes and are rusty brown. Very cute little fellas. Here's our first type of point mutation, missense mutation. It involves swapping one base for another that also code for a different amino acid than the wild type. I have circled where the mutation has occurred, and in this case, a T has been switched to a C. This is called a transition as they are both pyrimidines. This results in us swapping phenylalanine to a leucine. For our purposes, this mutation ends up coding for a protein that results in breakage of stripes to form spots. Our second mutation is called a nonsense mutation. This is when a regular codon is switched to a stop codon, cutting the chain short. In this example, an A is swapped for a U, making this a transversion because they are not the same classification. In this case of our Buntheras, the protein still somewhat works, but not as well as the wild type or missense. This results in peppered patterns and some loss of pigment. The third are silent mutations. These are actually rather common and they don't cause change in the amino acid sequence. A base is still changed, however it codes for the wild type amino acid. In our sequence, an A is changed to a C, so we have another transversion. You can also see that the AGG and the CGG code for the same amino acid. So in our Bunthera, silent mutations in the protein result in a regular striped coat. The last are read-through mutations. This is when a stop is turned into amino acid codon. So our original UAA is turned into a UAC, which will code for tyrosine, and so on. This greatly extends the protein until it reaches another stop. Another A is swapped for a C, so we have another transversion. In this Bunthera, their protein is completely dysfunctional, and it results in the loss of pigment completely. This is actually how most non-silent mutations go. It's rare that another protein is coded that works. However, I wanted to showcase the change of proteins in more ways than just it being dysfunctional. Thank you for watching. Have a great day.